Maura is sliding down an ice-covered hill with an incline at an angle of 21 degrees. If Maura and the sled combined have a mass of 63 kilograms, what is the force pulling them down the hill? And we have to remember that there's no friction since it's an ice-covered surface. So what I'm going to do to start off this problem is I'm going to draw a diagram. And so right now I'm drawing the ground, which is like the horizontal surface, and then we have the hill with an incline of 21 degrees. And then we're going to draw a box as Maura and the sled, and we're going to draw our forces now. So our first force that I see is force gravity, and then another force is force normal, which is always perpendicular to the surface. And what we're trying to find is the force pulling it down the hill, so that's a horizontal force. So this is going to be force tension or force pull. And so what we're going to do first is we're going to draw a triangle, and this is force gravity Y and force gravity X. And what we're trying to find is this force, and that'll answer that one. So this angle is 21 degrees because it's always the same as that one. So what we're going to do first is we're just going to draw a separate triangle, and we're going to, it's just like the one we drew here, it's just in a different space, 21 degrees. And then, so how to find force of gravity? We need to find force of gravity first and find these two. So force of gravity equals, mass times acceleration. And so the mass we have is 63 kilograms. So it'd be 63.0 times negative 9.8, because that's the mass on Earth. And so our answer we would get is negative 617.4. And so this would be this number, or this gravity. So we would put that as a hypotenuse. And this would also be newtons, sorry. And it'd be negative because it's also pulling it down. So we want to find this one. So what we have to do is we have to use sin, which is opposite over hypotenuse. So we don't know this one, but we know this one. So we're going to do sin with the angle of 21 equals opposite negative. Oh, so that'd be 0. And sorry, that would just be that would be the opposite. I don't think that's 0, but that's just the opposite. And then this is negative 617.4. So in order to get this number, we'd have to times these two. So we're going to do sin 21 times negative 17.4, which equals negative 221.3 newtons. And that's our answer for the force pulling it down, which would be this force, because this is the force. So this one would be negative 23, and so would this one. My problem relates to Newton's second law because Newton's second law is the net force acting upon an object and the mass of the object. And in my problem, I was trying to figure out the net force of the object that was getting pulled down the hill.
Hi, I'm Maura, and I'm going to be explaining Newton's third law, which is every action will have an equal and opposite reaction. So the story that I have here is Joe is trying to push an 80-kilogram box through the door. The box won't move if the coefficient of sliding friction between the box and the floor is 40. How much force is the box pushing back on Joe? So first, in order to find how much force the box is pushing back on Joe, I have to draw a diagram. So here's the box. And then I'm going to write all the forces that are acting upon this box. So we have force normal, which is going upwards. Force of gravity, which is going down. Then there's the force pushing or pulling, going out to the side. And then we have force of friction going the other way. So in order to find the force of friction, I'm going to need to use the formula force of friction equals the coefficient times force normal. But in order to find that, I first have to find the force of gravity. So the formula for force gravity is force gravity equals mass times acceleration, which in this case, the mass is 80 kilograms, and it's times a negative 9.8 meters per second squared, because that's what the acceleration is always on Earth, and that equals a negative 784 newtons. So then I take that and I plug it into this equation. So it's going to be force of friction equals 40, because in this we said that the coefficient of sliding friction is 40. So it'll be 40 times and then negative 784 newtons. And then that equals a negative 313.6 newtons. And that's how much force is pushing back on Joe. So for Newton's third law, for every action there's an equal and opposite reaction. My problem relates to Newton's third law because I had to find how much force the box was pushing back onto Joe.